So there are constant variable. That variable need to be has to be constant. Is the flow rate of the
Sorry, sir, I did not hear that before. Putus, sir.
okay. There are some factors that need to be constant. It is the flow rate in here. There is in the diagram this one. Oh, sorry. The diagram. There is a carrier gas. The carrier gas must be given out using a pump. So this is the flow control. So it controls the flow of the gas carrier. Cannot be too fast, cannot be too slow. Okay, depends on what we want to analyze. Okay, uh,
Oh,
yeah, we depends on what we want to analyze. As we know that some substances, some components exist in substance A, but we want to know how many percent is the component. Example, in drugs. In medicine, maybe use maybe in aspirin. How many percent of aspirin in the specific medicine, in medicine tablet? How many percent? We have to find using this one column and then given out on the graph paper as a peak at this time, or this corresponds to aspirin, and then we see the height of the peak. If the peak is too high or the aspirin is over too much, or the aspirin is according to the uh, guidelines from the uh, health ministry, okay, then if too much is also not good. Maybe become more effective, but it is not good. So that determines this component, the percentage of the components determines the price of medicine in the market. The same medicine that can reduce the symptom of flu, of influenza. There are many brands. Of course, they have different percentage of the components that
mm.
determines the
So
price.
this is what's used.
Yeah,
So this is what's used for medicine.
yeah, to analyze.
One more thing, sir. The sample injector, I believe you said it has to be liquid, right?
Sample injector, yeah, and then
Oh,
also it has to be volatile, make it easy to evaporate.
okay.
If less volatile, then what happens? Less volatile also can go inside the column.
So
It takes longer time to stay in the column.
so it will stay inside the column.
Yeah, If- but it will not stay forever.
So
It will,
teacher,
for sure, it will come out. And every time of this TLC use must must be time for cleaning. So every time of after running the test, this column must be cleaned, or we call as washing.
Otherwise,
Washing.
the next result will be contaminated.
Yeah, yeah, of course. Will if not washing properly, it will the result of the next test will be a lot of error. So
teacher.
yes,
So the more volatile the gas is, the longer it takes.
the more the more volatile, the faster. The
How
faster it
faster?
will give out. So there is a time response 5 minutes until 25 minutes.
Or so for that particular compound there are range, right?
Yeah, of course.
Like
Yeah. That we have to
oh
check in the reference. There is a reference table.
oh
Yeah,
so
because
the
our focus is not in chromatography, so the author does not give the reference also, and we are not becoming the laboratory technician, so it's not necessary for us to know the reference and how to perform it very well. Okay, so the use this one to detect the pesticides. We know pesticide is easy to evaporate. Like also it stays on the food. Also can be fungicide like bygone. For example, a person give uh, coffee to someone. Person A serves coffee, but in the coffee there is bygone. And then, so the person B collapsed and died.
Honestly,
Investigate.
I'd be more afraid if there was a fly.
Yeah. So investigate how many percent of bygone have been had put inside, and then also can also the to detect the steroid, anabolic steroid in sportsman to make the sport person perform better
Better.
during the game, and then also to detect the explosive residue on the skin or clothing. It doesn't mean the cloth has to be vaporized. If the cloth vaporized, it means the residue already vaporized first before the clothing become ash, become vapor. So we have to take the sample in using cotton buds, and then put inside the liquid.
TLC.
Yeah, and then goes into the sample injector to find what is the specific substance. This TLC is not the advanced one. It's not the advanced. The advanced is called as HPLC.
LC.
Yeah, HPLC. This one,
Artisan also.
excuse me. Okay, the more advanced is HPLC. The HPLC is the result is similar. How to read the result is similar to uh, TLC, similar, but the difference, this one is HPLC is more specific. Is using partition to separate the different solubility of compound. The stationary phase is non-volatile liquid. So it is not using the solid column, but there is also column, the HPLC column, stationary phase, and the solvent for the mobile phase is usually polar. And then this must force under pressure through the densely packed column where the separation occurs. So the more polar components in the mixture have greater solubility in the polar solvent. So they are carried through the column, and less components that is less soluble will dissolve better in the uh, non-polar stationary phase. So let me show you this one. Now, this one is the HPLC. Okay, so the HPLC, the solvent, there is a mobile phase and then pumping. This one is not using gas carrier. If if in GLC use gas carrier, this one is only use the solvent. And then there is a pump solvent manager solvent to adjust the flow rate of the solvent. And then there is a injector. This one um, for the column it is not given on our textbook. What is this one the explanation of HPLC? But I'm giving you the theory, which is in which there is an advanced method of chromatography called HPLC. And then there is a detector, and then there is waste, and then this HPLC is connected to the computer. And then
Chromatography.
yeah, more advanced connected to the computer. In this one, in GLC, give the reader directly on a piece of paper. So it is the calculation is quite not accurate, not specific. If using digital HPLC using on paper, it will be more accurate.
Accurate.
Yeah. Okay. Until here, is there any question for the chromatography? I think it's quite clear about the mass chromatography. It is not too difficult. Okay. After this, I'm going to show you what is the question look like. What the question looks like on the A-level paper, past A-level paper about this. Okay.
Okay.
Wait, let me share.
That'll work.
Wait, Nicholas. Wait, let me put it on Google Classroom as well, so you can see how
Okay.
it looks. Okay, wait, wait a minute. chromatography. Okay, still sending. Okay. Okay, this is what it looks like, the question. Okay,
In layer chromatography, absorption.
yes,
Chromatograph was
I
created to show.
I already attached on your Google Classroom. You can see on your Google Classroom.
Not yet updated. So let me
Not yet
try to update.
updated. Maybe it takes time.
No, usually it just says there's an updated stream updated.
Oh yeah.
Not this time though.
Okay,
Oh,
so
here it is.
what is the process that TLC?
Absorption.
Absorption.
Yes, it's not difficult, right?
Oh,
So
that part
Yeah,
isn't.
we have to know the concept on only, not this, not too specific. And then, is it already updated?
Yeah, yeah, it is.
Yeah, yeah. Okay. The amino acids have structures that are very similar. Of course, they have similar. Why similar? Because there is amine and there is a carboxylic acid. Just different R group, different side group. Suggest how this could explain how the student could analyze the chromatogram to identify the three amino acids that were present. So
Uh,
acid found in human chromatography, student use TLC to separate alpha amino acid in sample of human and discovered the three different amino acid were present. It is not specific what are what the amino acids are, what are the names, and then how to differentiate, how to analyze using TLC.
you put the sample in one spot and then try different alpha amino acids in different spots until well you used all of it, and then you use thin layer chromatography.
Yeah, thin layer chromatography. So we measure. We have to use the same solvent. We have to use the same solvent, and then we run the sample
Same
on a
on the same.
solvent, and then after that we have to check the RF value compared with
If it's the
reference,
same.
the reference RF values. Can you download? Have you downloaded?
Not download, more like it's already here in my Google Slides, and I can just open it up.
Okay. And then several amino acids have structures very similar. Suggest why this could cause problem when TLC analyze mixtures of alpha amino acid.
The
Actually,
RF value are
value it
ridiculously
is accurate.
similar, so it's
Yes.
Similar.
very.
Very
Yeah.
hard to see
The
when
RF
to compare.
values are similar because they have basically the same structure, same amine, same carboxylic acid. They can form isoelectronic different. We know that from the data booklet. When we check the data booklet, there are some amino acid that considered to be non-polar. So when non-polar with non-polar, they are giving the same response. So it's quite difficult. And then this one, number two, chromatography is an important analytical technique and used to separate mixtures into their individual components. Define the following terms used in chromatography. What is the meaning by RF value?
Retardation value. It is the how far the solute has traveled compared to the solvent.
Exactly. And then retention time.
This one I'm not so sure.
Okay, is the time between the retention time. Retention time occurs with
GLC.
yes, GLC with this one. So retention time is the time between injection and detection.
Oh,
So there is a time between injection and detection.
so it's almost like RF value, just with a different.
Yes. RF value. Does RF value have unit?
Don't think so. It's a
No,
percentage.
it doesn't have unit because centimeter divided by centimeter only form a number.
It's nothing.
But in GLC and HPLC is based on the unit is
Unit
time. Is the unit
seconds
is
or
minute.
hours.
Yeah, or maybe second. And then next, volatile organic compounds that enter soil via waste disposal sites affect the quality of the soil. A preliminary step in analyzing soil quality involves separation of these volatile compounds GLC. Using GLC. Name the process which compounds are separated during GLC. The separation,
Uh, it's not absorption, so it's partition.
partition. And then,
Oh, a process or partition.
yeah. What are the rules of the gas and liquid in
Gas,
GLC?
liquid.
Yes.
Yes, I think for reaction, but
The gas is definitely the mobile phase.
Gas, there is GLC here, there is a gas, and there is a injector sample. We inject liquid. Can we is the term for gas, is it injecting gas? It is injecting liquid.
No.
When we, so what is the rule of the gas for?
The gas is for the
You said,
yeah
you
um,
answered
mobile
already.
phase.
Mobile phase. And then the liquid,
Liquid is for I'm guessing the carrier.
no, the carrier is the gas. It is written here carrier gas.
Oh, okay then. I
So
thought then the color is the mobile phase, right?
yeah, gas is the mobile phase, and then the liquid is
um,
Is
I'm
it the
stationary
stationary
phase.
phase along with the
The liquid is the stationary phase.
so the column is the stationary phase, right?
Yeah, the role of the liquid is stationary phase. And then the third one,
Okay.
draw a diagram GLC for a mixture containing two components.
Two peaks.
Exactly. When in which any, as long as there are two peaks.
It doesn't specify.
No,
doesn't
doesn't
matter.
specify. Here is not it. It is not necessary for you to calculate how many centimeter and then and then you draw the first peak at which centimeter and the second peak at what centimeter. It doesn't need that specific as long as as long as there are two peaks
Height
showing
doesn't
two
matter right there.
components. Yeah,
The height.
different same height or different
Some
height,
height.
no problem
Same.
because the
Be safe.
reference is based on the time, not based on the peak, on not based on the
Okay.
height of the peak. And then explain how the GLC used to determine the percentage composition
Area underneath the graph times the
divided
what's the
by
peak? Okay,
total
the
area
Of
times
what is
graph.
the peak
100%.
divided the entire area of graph under graph?
Yeah. So this one
What?
components separated peak height divided by total area
Okay.
times 100%. So that is the percentage of the components. And then this one, chromatography is a versatile technique that may be used to separate and identify compounds. Name chromatography to identify the dissolved substance.
HPLC, paper
Paper
chromatography, thin layer
chromatography,
chromatography,
TLC,
as long
Yes.
as it's not
TLC.
GLC.
I
Yeah.
TLC.
GLC,
And
I don't think cannot. It must be volatile. This is dissolved.
yes.
Yeah.
Dissolve, it means it is volatile or not.
Don't think so.
Yes. State what quantitative value may be determined from the chromatogram to identify the substance present in the solution. What is the quantitative value?
RF value.
RF.
Exactly.
That's oh okay.
And then the third point, sketch a chromatogram. You can make any paper chromatography.
Preferably chrome paper because it's simple to draw.
Exactly. Do not draw GLC, do not draw HPLC, make the simple one. And then number 4 here, state the quantitative value normally identify components in any type is RF value. If
Uh,
guess
RTC,
if
right?
GLC the term
Retention
is not
time.
RF value.
MA. Oh,
Retention time, I believe. I
Exactly.
don't know how to call it.
Yeah.
time pokoknya.
Retention time. And then you have to sketch the chromatogram,
Peak,
sketch a chromatogram to show how the value is determined. Is
peak.
using this diagram. Using this diagram, so there has to be x-axis with numbers. The unit of x-axis is time per minute, and then the y-axis is recorder response. So this graph you need to write, and then you have to make only one or two. It's not necessary to make so many peaks. Okay, and then state the physical process, the separation in GLC. Separation method?
Partition.
Yes, exactly. So finish. Is it difficult?
Nope.
No, no, right? Not that specific. Uh, we do not need to calculate the retention time. We do not need to calculate the what is the percentage because chemistry here is not becoming chemical laboratory technician. If laboratory technician,
Can do
yes,
it. to do it.
You have to calculate. Okay, so for today, this is the class about chromatography, and tomorrow we will continue with different topic.
Okay,
Okay, good morning, and discuss again tomorrow.
got
Okay.
it.
Thank you,
Thanks,
teacher.
Joe.
Yes,
Thank you. Thank you, teacher.
yes,
Thank you, Jeff.
yes.